Hello everyone, welcome back to another video. Today we will be solving 51st problem of the Blind 75 series. The problem is longest repeating character replacement. The problem statement is you are given a string s and an integer k. You can choose any character of a string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Okay, so question says that you will be given a string s and an integer k as an input, and you can perform at most k changes in your string. And after k changes, like you have to perform changes in such a way that all the characters of that particular substring should be same. Okay, so you need to tell what is the maximum length substring you can get after performing at most k changes in your string. Okay, so let's understand this operation more clearly with the help of some examples. So the operation is you have to choose some characters from a string and change them to any other uppercase English character, and ultimately you have to make all the characters of that particular substring same. Okay, and you have to do this in such a way that you just get the maximum length substring that has all the characters same. Okay, so let's understand this operation more clearly with the help of some examples. So suppose you are given a string which contains the letters A, B, C, and D. Okay, so ultimately you have to make all the characters of a string same. Okay, so if the characters are A, B, C, D in the string, you can either change all the characters to A, or you can change all the characters to B, or to C, or to D. Okay, so if the length of a string is n, so at most you can perform, at most you, in the worst case, you will perform k minus n minus 1 changes to make all the characters same. Okay, here you can see that the length of a string is 4. Okay, so if I just randomly pick any character from this string and change all other characters to that particular character, so I will make 3 changes, right? So I can just keep this a intact and change all other 3 characters to a, or I can just keep this B intact and change all other characters to B. Okay, so in the worst case, for a n size string, we will perform n minus 1 changes. Okay, but as we want to maximize the length, and I have limited number of chances to make the change in the character, as you are given in the as you are given in the question, that we can perform at most k changes. Okay, so it is not like that I can just do any number of changes and then I will make all the characters of a string same. I have limited number of chances to change the character. Okay, so I have to perform this operation optimally so that I can maximize the length of my substring, uh, which contains all the characters same. Okay, so how I'm gonna do this, let's understand that with the help of this example too. Okay, so suppose now I have a string which has 4 characters as A, C, D. Okay, so I have to make all the characters same. Okay, I can change all the characters to A, or to C, or to D. Okay, so if I just randomly pick a character as I was doing in the example one, so what I will do, if I will choose C, so I will have to change all other 3 characters to C. Okay, so I will have to perform 3 changes. In the same way, if I just pick D and change all other characters to T, so again I will have to perform 3 changes, right? But if I pick A, so this A and these two A's will remain intact, and I will have to change this C and D to A. So in that case, I will perform 2 changes, right? So as I have limited number of changes, I will make changes optimally. I want that with minimal number of changes, my characters of a string should become same. Okay, so how I am gonna do this? So for doing that, what I will do, I want like minimal number of changes, or I can say that I want more characters of the string should remain same. So I will choose a character that has the maximum frequency. So if I will choose a character that has the maximum frequency, so because of that, more number of characters will the string will remain intact, and I will have to do less number of changes. So if I have to perform this operation optimally, I will always choose a character. I will always choose the most frequent character in that particular substring. Okay, so if you have understood the operation, so we can move forward in our question. Okay, so now what is the operation that we need to perform? I have to make all the characters of a string same, and this operation I have to do optimally, right? Okay, so as you can see here, if I want to do the operation optimally, so the minimal number of changes that I will make is length of that particular substring minus the frequency of most frequent character in that particular substring. Okay, so now I can break down my question as I have to find the length of the longest substring such that length of that substring minus maximum frequency of the character the frequency of the character that appears most frequently in that particular substring is less than equal to k. Okay, so now I can break down my question to this. Okay, so I have to find the longest substring that satisfies this condition. What is the condition? Length of a substring minus maximum frequency of a character in that particular substring should be less than equal to k. Okay, so what is the brute force solution for this problem? So whenever you are given the questions related to subarray and substrings, you can always use two nested loops to find out all the substring. So here you can use two nested loops. The first loop will go from 0 to n minus 1, and second loop will go from I to n minus 1. What you can do, you can just keep a track of all the characters that you are getting in that particular substring, and you can just use a hash map or a hash array to keep a track of the characters that you are getting in that particular substring, and you can maintain the maximum frequency that you have got so far in that particular substring. And at the end, what you can do, you can just check the length of a substring, and you can just do a check for this particular condition that if the length of substring minus maximum frequency, if it is less than equal to k. Okay, so then you can update the maximum length. So this is the brute force solution for this particular problem. So you can try it yourself and try writing down the code for this. Okay guys, now let's move towards the optimized solution for this problem. So the optimized solution for this problem uses sliding window technique. Okay, so sliding window is a popular technique that is used to solve array and string problems. So in sliding window technique, what generally we do is we just take a window, like we start with the minimum size window, we take two pointers that denotes the starting and ending point of a window. And what we do, we start with the minimum size window, we start with the window of size 1, and I just keep on extending the window until I reach a condition from where I cannot extend the window anymore. Okay, so whenever I will reach a point from where I cannot extend my window further, from that point I will start shrinking the window from the front side. Okay, so once the condition becomes true again, so I will again start extending the window from that particular point where I left. Okay, so this is the general template of a code which we write for sliding window problem. Okay, so next problem is also based on the sliding window. That is why you can just keep this template in your mind. Okay, so we will start with two pointers I and j, and I will just keep on it. This j denotes the end point of a window and I denotes the starting point of a window. So while my condition is true, I will just keep on adding the elements in my window, and I will just keep on extending the window. But once I reach to a point where my condition when the given condition for a window or a substring become false, I will start shrinking the window from the front side, and whatever changes I am performing in my substring or subarray, I will include those changes in my answer. And while you are doing this, whatever substring you are considering, you can just keep a variable to keep a track of the maximum length substring that you have got while you are doing these operations. Okay, so let's understand this more clearly with the help of code. So let's write down the code for this particular approach. Okay, let's write down the code for this approach. Okay, so let's store the size of this string in some variable. Okay, so I will take a hash array to keep a track of the frequency that I'm considering in the given substring. So I will name this as frequency. So it will be of size 26. As you can see here in the constraints, we are given that in our string we will have only uppercase English characters. So we can take a hash array of 26 size. Okay. So then I will take two pointers that will denote the starting and ending point of the substring that I'm considering. Okay. So initially both of them will be set to 0. Okay. So then I will need some variables like maximum length. So I need to find the maximum length. So I will just keep on updating this value whenever I'm getting the greater length. And I also need the variable maximum frequency. Okay, so initially I will initialize these two variables as 0. Okay, now let's start writing the code for the sliding window technique that we are going to use. So while j is less than n, so this j denotes the end point of the substring that I'm considering. So maximum j can go to the last index. So that's why I have written the condition why j is less than n. Okay, so whatever, like this j will keep on increasing forward. It will keep on moving in the forward direction. Okay, so whatever character is at index j, I will just include that character in my substring. Okay, so let's first store this character in some variable. Character ch is equals to s of j. Okay, now I need to include this character in my substring. So for doing that, what I will do, I will increase its frequency in this hash array. I will increase the frequency of this particular character in the hash array. So this means that I have included this character in my current substring. Okay, so I will do frequency of ch minus a plus plus, because I have taken the hash array of size 26. So this the zeroth index of this frequency array will denote the character capital A. First index will denote the character capital B. So if I want to find out the corresponding character for corresponding index for this particular character, I will have to uh, I will have to subtract the ASCII value of this particular character. Okay, sorry, I will have to subtract the ASCII value of capital A to get the corresponding index for this particular character. Okay, so now I have included this particular character in my substring. Now we'll check for the condition that if my substring that I'm currently considering, is it valid or not. Okay, so what was the condition? The condition was length of a substring minus the frequency of the most frequent character. It should be less than equal to k. Okay, so whenever I'm updating this frequency, let's update this maximum frequency also. So maximum frequency is equals to maximum frequency, and this frequency of ch minus a, this value that I have added now. Okay, so I will check for the condition that if length of a substring, so length of a substring will be j minus I plus 1 plus, sorry, minus maximum frequency. If it is greater than k, it means now my condition has become false. Condition is false now, so now I need to shrink the window. Okay, so I need to shrink the window. So for shrinking the window, I will remove some characters from the front of a window. So if I'm removing the character, so when I was here, when I was adding the character, I was including their frequency in my I was increasing their frequency in the this frequency array. Now when I'm removing the characters, so I will just remove the frequency of those characters. Okay, so I will do frequency of, I will remove the characters from the front side. So I will do frequency of s of I minus a. So now I will decrease the frequency and I will just increase a, sorry, just increase I. So it may happen that that my maximum frequency will change when I'm updating the frequency. So I will again use a for loop to keep a check of maximum frequency. So maximum frequency is equals to maximum frequency and frequency of I. Okay, So when you will be out of when you will be out of this loop, so you will be in a valid substring which will satisfy this condition, that length of a substring minus frequency of the most frequent character in that substring is less than equal to k. So you can just update your maximum length. So maximum length is equals to maximum length minus length of this particular substring. So that will be j minus I plus 1. Okay, and in every step you will just increase j. So at the end you can just return the maximum length that you have got. So let's try to run this. Okay, sorry, it will be maximum length comma j minus I plus 1. Okay, so it's working fine for sample test cases. Let's submit this solution. And yes guys, it got accepted. So what will be the time complexity? So here you can see that uh, I am just I'm using two pointers I and j, and in every step this j pointer is incrementing by 1. So this like in every step j will be increasing by 1. So in the worst case, I will just traverse the array twice. So time complexity will be big of n for this, and as the extra space that I'm using here is only this frequency array, and that is of size just 26. So you can consider this as a constant space complexity. Okay, so this is all for today's video. So we'll meet in the next video. Bye bye.